For most of the Cold War, rockets were built the way that medieval cathedrals were built, slowly, expensively, and with the assumption that nobody would ever make another one quite like it. Then SpaceX showed up and treated rockets like pickup trucks. The result quietly rewired the entire aerospace industry. Today, we're going to talk about how that happened, why nobody stopped it, and why the consequences are far bigger than cheaper launches. Hello, my name is Gene Botkin. I study technology and its effects on geopolitics, and I'm building a society for people who want to participate in the new space age. Our topic today is how SpaceX transformed the aerospace industry forever. Let's begin. For most of the space age, getting to orbit looked less like transportation and more like a rite performed by engineers in clean rooms. Rockets were treated as sacred artifacts. They flew rarely, carried enormous emotional weight, and were never expected to come back. Each launch felt like a museum exhibit briefly brought to life. The structure behind this ritual mattered. Governments defined the missions. Contractors wrote requirements into stone tablets disguised as documentation. Hardware was built slowly because nothing rewarded speed. Budgets grew because reliability was measured by paperwork and not flight history. When a launch vehicle flies once, every few years, failure becomes unacceptable. That pressure pushes engineers toward extreme caution. Designs freeze early, components are overbuilt, entire subsystems survive unchanged for decades. The goal stops being improvement and becomes avoidance of embarrassment. This environment produced miracles. It also produced prices that drifted upward until no one remembered why they were so high. $100 million per launch sounded reasonable because it had always sounded reasonable. Commercial demand barely existed. Universities, startups, and small nations were effectively locked out of orbit. Space belonged to governments, and the contractors licensed to serve them. And by the early 2000s, the aerospace industry had achieved something impressive and slightly tragic. It had learned how to reach space reliably, and then it forgot how to change. And that was the world that SpaceX entered. Not broken and not failing, frozen. The popular story says SpaceX shocked aerospace by landing rockets. That part looked good on thumbnails, but the deeper rupture came earlier. SpaceX approached launch vehicles as machines meant to be built often, flown often, and improved constantly. In traditional aerospace, a rocket was closer to a crown jewel. You admired it, you protected it, but you never experimented on it in public. Yet SpaceX did the opposite. Failure was assumed. Explosions were filmed, archived, studied, and immediately fed back into design. Engineers were expected to learn faster than embarrassment could spread. The company treated each failure as tuition paid to reality. This mindset clashed violently with legacy norms. In established programs, a launch failure triggered investigations, hearings, and frozen budgets. At SpaceX, it triggered a meeting and a new weld pattern. The company accepted something others refused to say out loud. Rockets fail because they have not flown enough. The cure is repetition and not perfection. And from that assumption came rapid iteration. Engines were redesigned between test flights. Structures changed mid-program. Software updates moved faster than procurement officers could blink. Reusability was not the starting point. It was the inevitable conclusion. If rockets are machines, then discarding them after one use makes about as much sense as scrapping a truck after a grocery run. When Falcon boosters began returning from orbit, the industry stopped laughing. It recalculated and quietly realized that the old rules were gone. Once SpaceX drove launch prices down, the damage spread far beyond rockets. For decades, satellites had been designed around terror. Every kilogram cost a fortune to lift. Every failure risked ending a career. And the result was hardware built like porcelain statues, beautiful, delicate, and wildly expensive. But cheaper access to orbit shattered that logic. Suddenly, mass mattered less. Satellites could be smaller, simpler, and replaced rather than immortalized. Engineers stopped treating each spacecraft as an heirloom and started treating them as inventory. That single shift unlocked an entire ecosystem. CubeSats escaped classrooms and entered commerce. Earth observation moved from occasional imagery to persistent surveillance. Communications constellations leapt from whiteboard sketches into orbital reality. But the most important change was psychological. Launch stopped being terrifying. When a rocket flies once every few years, every mission must succeed. But when launches happen weekly, failure becomes unpleasant rather than catastrophic. Iteration replaces paralysis, and speed beats elegance. Starlink emerged from this environment, although it was not the only beneficiary. Planet, OneWeb, IceEye, and dozens of smaller firms rode the same cost curve downward. And so launch became infrastructure rather than spectacle. And that terrified companies that built on scarcity. But it delighted anyone who wanted scale. The aerospace industry had spent half a century optimizing for rarity, but SpaceX flipped the axis and optimized for abundance. Once that happened, the old business models cracked quietly, and then all at once. Legacy Aerospace was built like a medieval marriage alliance. Engines from one house, structures from another, avionics from a third. Integration meetings served as diplomatic summits where nothing moved quickly and everyone guarded their territory. Yet SpaceX ignored this custom entirely. They built engines themselves, they wrote their own software, they designed avionics in-house and treated flight computers, less like holy relics and more like rugged laptops with ambition. If something broke, they did not renegotiate contracts, they changed the part. This vertical control compressed timelines brutally. A design tweak that once required months of coordination could happen in days. Engineers sat close enough to hear each other complain, which turned out to be a powerful management tool. The old system, however, optimized political safety. Spreading work across contractors created congressional support and budget stability. It also created inertia heavy enough to bend time. SpaceX optimized for velocity instead. That choice carried risk. Vertical control means absorbing blame as well as credit. There is no supplier to point at when something fails. SpaceX accepted that bargain willingly. Meanwhile, competitors tried to imitate the structure and discovered the problem. Vertical control is not a chart, it is a culture. It requires trust, internal competence, and tolerance for discomfort. Yet many aerospace firms are federations pretending to be companies, while SpaceX behaves as a single organism. And organisms adapt while committees schedule meetings. And only one of those thrives in a competitive environment. In the old aerospace world, speed was treated like recklessness. Flying too often meant tempting fate, and each launch was expected to feel momentous, preferably with a commemorative patch and a catered lunch. But SpaceX made frequency boring. Falcon 9 began flying again and again, then again the same month, then again the same week. What once felt extraordinary became routine, which is exactly where power hides. High cadence creates experience, and experience compounds. Every flight produces data. Every landing refines refurbishment. Every anomaly sharpens reliability. The rocket improves because it is used and not because it is discussed. This feedback loop cannot be simulated. Wind tunnels do not replace repetition. Reviews do not substitute for flight history. Cadence is knowledge earned the hard way. As launches multiplied, reliability improved rather than declined. That inverted decades of aerospace intuition. Flying more made the system safer. Governments around the world noticed. Militaries noticed faster. A launcher that can fly frequently is not a luxury. It enables rapid replacement of satellites, responsive deployment, and sustained presence in orbit. Space stops being symbolic and becomes operational. Although SpaceX did not design Falcon 9 as a military tool, it built the fastest learning machine in the launch market. And doctrine followed hardware as it always does. Once a company controls cadence, it controls tempo. And in any domain that matters, tempo quietly decides who sets the rules. Falcon 9 changed the pricing, but Starship threatens to change the arithmetic. The vehicle ignores nearly every aesthetic instinct of traditional aerospace. It is tall, reflective, blunt, and assembled outdoors like agricultural equipment. Stainless steel replaced exotic composites, and welding replaced ceremony. The message was clear: scale matters more than elegance. Starship is designed around volume, massive payloads, large fairings, frequent flights, and full reuse. The goal is not incremental improvement, but overwhelming capacity. Even unfinished, it has already bent planning assumptions. Lunar architecture studies quietly rewrite mass limits. Orbital depots reappear in serious documents. Mars stops being framed as theoretical. Programs designed under scarcity begin to look theatrical. Yet Starship treats orbit like a shipping lane rather than a destination. If Falcon 9 made space accessible, then Starship aims to make it crowded. The development process unsettles observers. Prototypes explode, test articles are stacked rapidly, failures occur in full public view, and this alarms traditionalists who prefer mistakes to be hidden behind reports. Yet the pattern is familiar. Fast construction yields fast learning. Hardware answers questions that no model can. Whether Starship succeeds exactly as planned is almost secondary. Its existence alone resets expectations. Once someone attempts scale openly, everyone else must explain why they are not. And that lifts the ceiling. Governments cannot unsee it. Competitors cannot ignore it. The future begins speaking louder than the past. And aerospace has to listen. And so SpaceX altered geopolitics without issuing a press release. Launch capacity, once distributed among national programs, concentrated rapidly within a single firm aligned with a single state. That shift happened through spreadsheets rather than treaties, and that made it no less real. American allies benefited immediately. Affordable access to orbit became routine. Missions launched faster. Replacement satellites could be flown without years of planning. And smaller nations gained reach by purchasing rides rather than building rockets. Rivals adapted uneasily. Countries that prized launch independence discovered that it was expensive to maintain pride. Many now purchase launches from the very system reshaping the balance of power around them. This concentration raises uncomfortable questions. Who controls access during crisis? Who sets launch priority? And who decides when capacity is conveniently scarce? The line between commercial provider and strategic infrastructure grows thin when one company launches more mass than the rest of the planet combined. And so, although SpaceX did not seek geopolitical authority, it accumulated it through capability. And that is how power usually forms. Policy frameworks lag behind reality. Treaties assumed national programs, procurement assumed competition, and neither anticipated a private actor operating at continental scale. The result is a strange hybrid. Markets move orbital assets, but governments rely on them, and strategy emerges from logistics. So space power now flows through factories and launch pads as much as through ministries and flags. And once infrastructure shapes geopolitics, it can no longer return to neutrality. The world is still adjusting to what that means. For half a century, spaceflight followed a cathedral model. Rockets were built slowly, revered deeply, and altered reluctantly. Each vehicle carried tradition, prestige, and a quiet fear of change. Yet SpaceX replaced that with a shipyard. Shipyards build often. They expect mistakes. They improve through repetition. The product matters less than the process that produces it again tomorrow. That shift is irreversible. Engineers entering aerospace now expect rapid iteration. Investors expect hardware to evolve. Governments expect launch systems that respond on operational timelines rather than political ones. The transformation goes deeper than economics. Space is no longer approached as a monument to national greatness. It is now treated as terrain. And once that mental change occurs, everything else follows. Infrastructure replaces symbolism, and throughput replaces pageantry. Cadence replaces ceremony. Other companies will copy elements of the model. Some already have. Few will replicate the culture that made it work. And the aerospace industry has forever traded reverence for momentum. And momentum has a habit of carrying peoples forward, whether they plan for it or not. And so, space is no longer waiting to be reached. It is waiting to be used. If you found this video useful, then like it, comment below, and tell us what you think will define the next era of spaceflight. And then subscribe to this channel if you want more analysis on space, technology, and geopolitics. This has been Gene Botkin with Elenarda. End transmission.